So good morning, everyone, and welcome to our final live session of the WaPPlugin Hackathon, From Database to Application. My name is Lauren Zielinski, and I'll be moderating this live session today, along with help from Hans van der Kwast and Simon Schevalking. Karen Bremer usually hosts with me, but she's not feeling well today, so let's hope she feels better soon. As you probably know by now, this hackathon is all about WaPPlugin. For those who are new to the event, WaPPlugin is the FAO portal to monitor water productivity through open access of remotely sense-derived data. It is a publicly accessible, near real-time database using satellite data that will allow monitoring of agricultural water productivity. And it is also the platform on which this hackathon is based. So during this hackathon, the participants have been challenged to think of ways to move from the WaPPlugin data portal and other linked open data sets and be able to use them to create easily accessible technical applications that tackle challenges on the ground. For those, again, joining us for the first time today, this hackathon is being put on by the WaterPIP project, which stands for Water Productivity Improvement in Practice. We are a consortium of knowledge institutes based in the Netherlands with the goal of improving water productivity in the agricultural sector using WaPPlugin. So the partners implementing this hackathon are IHE Delft, Institute for Water Education, Mete Mete Research, and Wageningen University and Research, with active support from FAO and ELIF. And we also have financial support from the Ministry of Foreign Affairs of the Netherlands through the IHE Delft Partnership Program for Water and Development. So 3 weeks ago, we started this hackathon. During week one, the teams worked together to come up with detailed concepts, which they presented in a 1-minute video pitch. After that, the jury selected 5 teams to continue in the competition to further develop their ideas. And these are the 5 teams we're presenting today. So during the last 2 weeks, these teams finalized their ideas and worked towards building a prototype. And today they will compete for the final prize. So let's quickly go over the program and introduce the jury members, and we can talk a bit about the scoring as well. So let me open my presentation. So just again, welcome everyone for today. The agenda is I'll quickly go over the rules as well as the judging criteria and introduce the jury members. And after that, we'll show the video pitches and we'll have a Q&A session for each team. So we have 5 teams today that'll take about an hour. After that, we'll have a short break so people can get up and move around, maybe get something to drink. While we take our break, the jury will then leave and they will take a look. They'll review the pitches and the Q&A answers, and then they'll make their decision on the final winner. But during that, we have a guest speaker with us, Kees Oude Lenferink. He's from the Netherlands Space Office, and he'll give about a 15-minute presentation, and we'll have a chance for a Q&A session with him as well. After that, we will welcome the jury back into the room, and they'll announce their results, and then we will close the hackathon. So the rules, each team will show their 5-minute video pitch, which they've recorded already, and this is followed by a 5-minute Q&A session with the jury members, and everyone will be able to see this Q&A session. After all the pitches are shown, we'll take a break and then have our guest speaker, at which point the judges will have about 25 minutes to discuss and choose their final winner. And then they will come back and tell us who the overall winner is of the hackathon. And we will continue to work with that team on making a plan and further developing their app, and including some outreach of their idea through the different WaterPIP partners. But we'll also continue to support the other finalists as well if they're interested to continue. So the judging criteria is similar to last week. We have adjusted it a little bit. So for 10% of the score, we have the expected impact. So what is the challenge that each team has decided upon, and what's the impact of this app on that challenge, as well as the users that they're targeting. The next thing, worth 25%, is a clear description of the user experience. So we want to know how the user would interact with the app. How does it feel like? Is it easy to use? For worth 25%, we also want to know a detailed description of how your app uses WaPPlugin data. So some people call this sort of the back-end development. How does it work with the different technical components and servers and APIs and those different kind of components? For 15%, we take a look at how innovative is your app. Is it something that already exists and you're improving upon it, or is it something totally brand new and and bringing in new life into the field. And last, we talk about the viability of the app. So thinking about the business plan. If this costs money, how will you raise money? How will you outreach to your target audience? Where will it be hosted? Those kinds of questions. And in addition, we also take a look at the overall pitch quality. So is it engaging? How are the graphics? Things that make it interesting for us as viewers. And then the coaches have been working with these teams for the last 2 weeks. So then we get a say, and we make a comment about how well the team communicated and engaged with the platform. So now I would like to quickly introduce the jury members. I think if you joined us last week, they look very familiar. These are all experts in the fields of WAPPLugin, water productivity, hydrology, and app development. The participants, again, they know them, and we're happy to have our jury members back with us again this week. So a big thank you for volunteering your time to be with us this morning. Our first jury member is Rami Boujode from BerryTech, which is a dynamic ecosystem for the creation and development of Lebanese startups, which fosters innovation, technology, and entrepreneurship. Rami joined BerryTech in 2014 as the Deputy General Manager, where he supports the Lebanese startups for business support, mentoring, coaching, fundraising, hosting, networking, and internationalization as part of the Innovation and Entrepreneurship Regional Program. So I think he's a natural choice to be with us today. Our second jury member is Anna Marie Klaassen from eLeaf. She has over 20 years of experience in the use of satellite Earth observation data and algorithms for environmental applications. Currently, she leads the FRAME consortium that provides the open access satellite-based data in the FAO WAPPLugin database for monitoring of and reporting on agricultural water productivity over Africa and the Near East. And today, last week, we had Gregory Giuliani with us. Unfortunately, he wasn't able to join us today, but he does wish all of the teams good luck. Lucky for us, Job Klein was very kind and agreed to be our third jury member. I think many of you remember him from last week as our guest speaker. So Job is a former diplomat in water diplomacy affairs of the Ministry of Foreign Affairs of the Netherlands and the first secretary of the Netherlands Embassy in Sana'a, Yemen. And here is where he initiated with FAO the first open source tool, WaPPlugin, to manage water security. So he was here from the beginning. We're happy to have you here today. Our fourth jury member is Domitille Vallet, a chief technical advisor for the Food and Agricultural Organization, the regional office for Near East and North Africa. He is an agricultural specialist with 25 years of experience in different regions of the world. Currently, she coordinates a regional project on water sustainability and agriculture in the NENA region that uses water accounting to inform decisions and sustainable development strategies. And our fifth jury member is Steven Dietrich. Steven is trained as a geoscientist and helps coordinate various international networks, including the Global Terrestrial Network Hydrology and UNESCO Friend Water. His research focuses on the analysis of hydrological variability across time and space, focusing on internal climate variability and climate change, as well as fluvial sediment transport. But you all get to be jury members too. So keep track of your favorite pitch as you watch them today, and you can vote for them during the break. So now let's get started with our teams. Last week, we went from the lowest team number to the highest, and so this week we thought we would switch it up. So our first team today will be Team 36. Their team name is Grazing Guide, and they are working on the theme of communication to smallholders. They have a team of 4 from all over the world, including the Netherlands, the Gambia, Germany, and Tanzania. So let's see their video pitch. So now I'll hand it over to Hans.
Pastoralist decision-making. Pastoralists have been dealing with climate stresses for time immemorial, but recent increases in climate variability stretching even their resilience to the max, with less grazable lands and more conflict between farmers and pastoralists as a result. Grazing Guide hopes to increase this resilience by reducing the distance between the pastoralists and grazing data, made available by, for example, satellites. This can be used to support the local strategies and mitigate risks associated with climate variabilities. Pastoralists are end users. To help them access information, we suggest a middleman approach where an individual who has internet access communicates the results of our grazing analysis. Though our final approach will be created with the users themselves, we propose a public list of these individuals, their location, and how to contact them. This allows Grazing Guide to use existing communication infrastructure within these pastoralist communities. To illustrate their interaction with the web page, we present a very rough user flowchart. Here you can see our two main functions, a language change and an annotation making function. The user has their own map on which they can comment for themselves. To demonstrate this, Katrien will play a pastoralist and I will play a middleman.
Hello, I need to find forage for my livestock. Usually I would send a young man from our community to scout all the grazing areas, but this takes several days and my livestock is hungry now. So I'm going to call my grazing guide contact. Hey man,
Hi.
Can I graze my cattle at the mountain?
Let me check. I'll just type in my personal username and password, log in, and now I see my own personal map. I look at the mountain and yes, Katrien, the grazing analysis of Grazing Guide says that it is good and I have no personal annotations to it. So yes, Grazing Guide says it should be okay.
Thank you very much.
Good luck. As you can see, it was a very basic approach to how Grazing Guide would work. In the future, we want to further develop it with the end users themselves. This includes, for example, the level of customization in the grazing analysis. To explain this further, I give the word to Katrien.
The data sources we are using are the WAPPlugin net primary production, land cover classification, and daily precipitation. For the prototype, we are importing the images into Google Earth Engine. We also include the Landsat 8 NDVI data from the Google Earth data catalog. End users of the app can add additional data for palatability and control checks via annotations. We show a calculated grazability score for the areas. First, we determine the land cover. If it is not grassland or shrubland, we categorize it as ungrazable. For the potentially grazable areas, we look at the net primary production and determine thresholds for grazable, possibly grazable, and ungrazable. We then add the precipitation from the last 3 days. The grazability index is what we think could be a useful calculation, but we will work together with the communities to adapt these to their feedback. Additionally, the users can use the app settings to change the grazability score calculation, for example, which land cover they want to include and what thresholds they want to set. The prototype currently looks like this, showing the 3 different grazability scores per pixel, masked by the grazable land cover type. Our next data steps will be showing the median grazability index based on connected areas and integrating more data sources like higher resolution NDVI data, land ownership data, and precipitation forecast. And we automate the integration of WaPPlugin data. The business plan is looking for donors from universities, NGOs, and governments, register as a not-for-profit, and work with local experts, developers, and communities in co-creation. We will then phase out developing a financial, legal, and social future plan and giving ownership to the pastoralist unions and focus on the ownership transition. For the marketing, we will work with partners who have already contacts in the area, unions, local governments, and NGOs. We will look for possible partnerships like other applications in the market, such as AfriScout and Maris, who already have a solid reputation. And we will use word-of-mouth marketing through our strong co-creation with local communities. Thank you.
Great. Well, wonderful video. Thank you for sharing with us. And now it's time for the Q&A with the jury. So with us in the room, we have Sebastian and Katrien from Team 36. So please turn on your cameras and microphones, as well as the jury members. Please do the same. We now have 5 minutes for Q&A. So I'll start the timer, and jury members, you can begin.
Good morning, everyone.
Good morning. I have a quick question. I was wondering, I don't think you spoke about the where the application will be stored, managed in your plan.
So for now, at least for the prototype, we use Google Earth Engine, which hosts the application.
Okay, thanks.
Okay, hello, thank you. I was wondering, you speak about ownership, but who is going to maintain this app once it's owned by the pastoral unions?
That is something we still have to see, because we don't we want to give ownership to the end users themselves, but we still don't know how to bridge that that maintenance gap. And that was also in the fourth step of our business plan, is really make a plan for the future with the resources that we have. So sorry to disappoint, but we're not quite sure how to do that yet.
I don't mind asking another question. Anyone else in the jury?
Yeah. Stefan, your mic is on mute.
Oh, sorry. Thank you. I have also a question. You had this nice interplay with communication with each other in different roles. How do you transfer the location? I think you need the location where the patrolists are actually staying and where he wants to move on to. How do you communicate the coordinates?
Do you mean of the pastoralists themselves or of the middleman?
Yeah,
Because,
when I got it right, the idea is that you call a kind of call center and say, okay, here I'm staying with my livestock right now, and now I want to move on. What is a best way, and where the best next cell to move to?
Yes. Well, first, a call center is not how I would describe it. I would describe it as someone in the community themselves. You also have pastoralist unions in place,
Yeah.
and these would be people who have already contacts within these pastoralist communities. There is a big mobile and internet penetration in these communities happening right now. So we're sure that there is someone who is connected to the other pastoralists. George from our team has expressed this to be true as well. So how they would communicate their location is not via coordinates, but more via the local language and culture. And this is also,
Okay.
Yeah, I hope that answers your question.
Yeah, thank you.
Hello, this is Rami. Very interesting presentation, well done. The first question is, have you tested or validated that this will work with the local community? Do you have any 2 or 3 people from those, groups of the unions to validate that this works? That's one. 2, have you seen anything similar to this app taking place in other parts of the world?
Thank you for your question. First, we have not spoken to the end users themselves. We do have someone in our team, George, who was unavailable for today, who comes from northern Tanzania, and he has shared with us the need for this kind of application, and also the communication infrastructure there where it will be placed. But that would be the next step, to really validate if it could work. And the second question, yes, we found at least 2 different apps that ran around the same idea. One of them is AfriScout in southern Kenya, or Maris, which is also in the same area. And how we really want to differentiate ourselves is first our ownership, our co-creation, and also the price it takes, the level of how do you say that? We want to make it easy to use for the pastoralists themselves, and also we use mobile network instead of an internet network as opposed to the others, to really penetrate deeper within the community.
Okay.
And I think we're out of time, but Job, if you have a quick question, I think you can fit one in.
Yeah, well, yeah. It's the same. I mean, a good presentation. What I would like to know, I think it looks quite laborsome. I mean, do you always need somebody to answer directly, or do you work with automate it in a certain way that it will be done automatically, or do you need always somebody on the phone? Thank you.
Well, end users, the pastoralists themselves, still do not have access to the internet, so automation would have to work with a mobile network. We haven't looked into that option, but we could, and we definitely want to automate the data analysis itself. I hope that answers your question. And thank you for all of your questions and interest in our presentation.
Well, thank you, Team 36. Grazing Guide. So I think really interesting Q&A. I enjoyed it. Nice questions from the jury and nice answers from you. So congratulations.
Thank you.
Thank you.
And so now I think we'll move on to our second team. So our second team, 30, they have the name Gaming for Crops, and they're working under the theme also communication to stakeholders. So they have 5 states from Spain, Bangladesh, Italy, the Netherlands, and India. So let's take a look at their video pitch.
Water scarcity is a growing nightmare for agriculture all over the world. We blame climate for increased droughts. But think again. The way we allocate water is to blame. We should rethink the way how we plant crops. We should reassess the way we allocate water. And we should recompose the rhythm and pulse of water demand. And so we present to you the Crop Diversification app. Our app gives you insight in monocropping versus crop diversification, improved regional crop plans as a result of group decision making, how crop diversification can help to build a sustainable water allocation strategy. Let's elaborate the challenges of the current situation. All our farmers choose the same, what we call an optimal crop. All crops now demand water at the same time. By introducing crop diversity, we introduce a redistributed and improved water demand scheme, balanced in season, balanced in peak demand. Let me give you a visual representation of the user experience with crop diversification. We introduce you to our main clients, the local community of farmers. We organize a community gathering, the icebreaking session. In nerdy terms, we call this the Water Union Association. Think of it as a brainstorming session. What is the current situation of your farm? What do you plan for the upcoming season? And what is your neighbor planning? The regional officer collects this information and enters it into the system. Our system now collects this field information and combines this with existing databases, which is a combination of vapor data, to mention a few, historical data, evapotranspiration data, seasonal biomass production, CropWatt, FAO soil portal, moreover data extracted from external data sources such as NOAA and CHIRP's data on seasonal forecasts. Now we are in the data analysis phase. This is where expert knowledge steps in. The combined effort will evaluate water demand versus water availability. Furthermore, it generates and suggests alternative cropping options for the specific regional settings. This is delivered through the app and shared with all the farmers. We enter a new round of shared decision making. The challenge is now on the farmers. They have to agree upon the suggested cropping patterns, make a shift from the very high demanding crops and alternate with some of the less demanding crops. In effect, we are now reallocating limited water through provides an estimate of yield and water demand, and it generates alternative cropping patterns. These alternative options are brought back to the farmers, thus completing the loop of information flow. We choose Syria as the pilot location of our project, Al Ghab in the Orontes Basin. Our choice of location has both pros and cons. Let's start with the cons. Because of the war, Syria is in a data-poor situation. Institutional structure has fallen apart. We aim to use these comms as our tools. We can begin to develop a framework around existing agricultural institutions. Use the existing regional groups that are there and that we are in contact with, giving them a valuable task. The app will therefore help to coordinate with international, national and local organizations. And by this app, we can now start collecting data for Syria to feed into the WaPPor database. Drop diversification. Let's rethink, redesign, recreate to reallocate water.
Great, thank you, Team 30. Great video, very exciting to see the work that you've done over the past few weeks. So now it's time for their Q&A with the jury. We have Willem and Kamar with us today from Team 30. So please turn on your cameras and microphones as well as the jury members. And then I can start the 5-minute timer. So you're welcome to start, jury.
Okay. I have a question. I may have missed it, so thank you for this nice presentation. I may have missed it. I didn't see a reference to market issues in the decision-making process of the users of the application. How do you address this? Because that influences farming decisions.
Okay, well, we have to consider Syria as a difficult situation at the moment. We do have contacts in Syria with the Water Association Club and the regional settings, and we need to build from there. What we basically try to do is set up local communities, make them talk about their cropping plans, and build from that into a higher level. But I think the first step is definitely start building local communities around this idea and start making them work. And that, I think, is our major challenge for the coming month. And I think Kamar wants to add to that, maybe.
Okay, thank you for the question. So basically, because there were some experience in Syria for, I can say, the local farm schools by ICARA. So we know that the community is open to try this new thoughts, if I may say, or new applications. And that's where we're trying to build on, as William said. So our plan is to start with the local community. And I must say, one of our team, Rasha, she is from the area that we're interested to work in. And so we have the communications, we have the first step, I must say, and what we're trying is to build on that. Thank you.
Just a very nice presentation. Thank you. Is it really something that is for a community, or is it also for individuals? That was not clear. Will it fail if the whole community is not participating? Could you say something on this?
Well, it definitely addresses cropping plans of regions. So you do have to talk through communities. If an individual farmer works with this, the individual farmer, his cropping plan will be okay. There will be water for that. But it starts to become an issue if all the farmers in one region start to build the same cropping plan. And so you definitely need the group process to be working. It needs to be a regional cropping plan, I would say.
Great presentation. My question to you is the following. So you're talking about regional planning. Have you validated who would be your client? Is it a cooperative in a particular region? Is it a governor in a particular region? And who will pay for your services on the long run?
Well, as said before, Syria is a difficult situation to get this kind of things working. And I'm not sure if we can talk about working institutions at the national level at this stage. So we are dealing with local communities, and we do have contacts with them. Kamar has a group of people who are willing to try this, and Russia comes from the area, so we do have the contacts there. We build from there. If that turns into something useful, it is basically the community who is doing the work. So, and they are doing the work for their own benefit. So we are not heavily dependent on technology, on services that we are providing. So there should be ways to figure that out, I would say. It's not our main problem.
If I may add, so basically for now in Syria, there's a group of farmers and engineers are being trained to use WaPPer and Google Earth Engine. And we are in connecting with them. We are connecting people from GORS, which is the General Organization of Remote Sensing in the country. So we know that the community and the organizations in the country are open to this new experience. But as William said, it's difficult in a matter of signing or like connecting now because of the country situation. But the people are there. We do have the connection inside the country, and the logistic or administrative things, I think, will come later once we. Thank you.
Thank you.
Great. I think we have reached our 5 minutes. So I want to thank the jury members and thank Team 30 for your great answers. It's nice to see the thought process and the on-the-ground connections that you guys have. I think the live stream may have paused for a moment during when we watched their video. So if you missed it, if you're viewing on YouTube and you missed it, we will post all of these pitches on our YouTube channel later today. And so with that, let's move to our third team. So let's go to Team 17. Their name is the WAPPlugin development team, and they are working under the theme Big Data for Water Management. They have 5 team members, which are from Tunisia, Colombia, Sudan, Zambia, and Egypt. So Hans, let's play their video pitch.
Currently, there are a large number of platforms that collect information of several water parameters worldwide. In most of the cases, the data is stored by public and private institutions, which usually make the information difficult to access and difficult to unify. Many platforms for processing the information exist, which make it visible and understandable for people involved in water management. Despite this, the connection between platforms and softwares is not easy to use and is time-consuming. For this reason, a QGIS plugin which will help in addressing these challenges is proposed, and even give their user the facility to compute indicators that will support the decision-making by the water professionals. The idea is to develop a water accounting and productivity plugin for QGIS software that will help water management users to provide an interface for calculating water accounting indicators based on WaPPer datasets. These indicators will support users by generating maps and reports for further assessment and evaluation, making the water accounting computation by water professionals simple and easy to use. A survey has been done in order to know how the user will interact with the plugin and how valuable is it for him. We have received more than 60 responses from 18 different countries around the world. People interviewed belong to different professional fields. In order to know if there is a similar plugin that people are using, we have received 88% of responses answering no. People that answered yes to this question mentioned different tools, but actually none of them has the same functionalities as the water accounting and productivity plugin. This confirms how innovative. The plugin has a forecasted customer base of potentially 20 governments, over 5 cooperating partners, many more universities, and countless QGIS users and developers. Planning on developing the plugin will be made up of market research, international campaigns, the research and development of the plugin, and subsequent add-ons. Aside from the €1,000 seed fund, the WAP plugin team will raise funds through consultation fees, water plugin tailor-made products, training of partners, clients, investors, and cooperating partner funding. First step will be to publish the plugin on QGIS, where it will be tested and checked for bugs. Tasters will be recruited from social media through Facebook, Twitter, GitHub, and LinkedIn. To raise anticipation of EIS users and water professionals, the team will write articles and papers that will be published in popular platforms such as EIS Launch. Water Accounting and Productivity plugin will be officially launched on the 15th of March 2021 with its source code in GitHub repository. The WAPPlugin management team will until then run promotional webinars, MAPI hours, and virtually launch party for individual users and plan pitch meetings and networking calls with potentially funders and investors. Although the Water Accounting and Productivity plugin has a user-friendly interface, the level of expertise in QIS is crucial to know how well could the user interact with the plugin. In this survey, the majority of the respondents have a medium level using QIS, which is enough to effectively operate data. When we have raised the issue of paying for WAP plugin services, 56% of QIS users are not willing to pay for such a tool. The plugin has two main features. The first one is for downloading the WAPR data directly from QIS. This feature will have access to the entire WAPR catalog as it is shown in its official website. The WAP plugin will guide the user to select the type of data he wants to look after and fill all the required parameters, in which the user will choose the resolution, location, dataset, and time series needed, and will be able to add the map selected directly in the QIS canvas as a raster layer. Furthermore, the second feature of the plugin is the calculation of water accounting and productivity indicators based on WAPR data. The indicators computation will be done entirely by the plugin, and in some cases it will require information from the user. The way for proceeding starts with the indicator selection by the user. Moreover, it will choose the time range, the resolution, the location, and the units. If it is required, the plugin will ask the user for some information, specifying the units that the data should have. The results will be shown as a map, which will be added as a raster layer in the QIS canvas. Most of these indicators reflect the impact that agriculture has on water resources, as being the most significant water user worldwide, and their analysis will help to identify specific issues that can be addressed by policymakers, large-scheme irrigation managers, river basin authorities, among others. Some examples of the indicators that are included in the plugin are the overall consume ratio, the depleted fraction, the overall field application ratio, and the crop water productivity that assess and diagnostics the irrigation water management. The scope of the plugin for now is the same one from WAPR platform, and as WAPR improves its coverage, the plugin will do so as well. Moreover, as a long or mid-term target, the WAP plugin will also open the access to other data sources as Aquastat and databases from several hydrometeorological institutes, opening the door to future partnerships. For the plugin to continue improving, at the moment there is already a repository on GitHub configured for the participation of several contributors.
Great video, Team 17, and congratulations. Now it's time for the Q&A with the jury members. So we have Natalia and Margaret with us today. So if you could turn your cameras on and your microphones, and I will ask the jury to do the same thing. We can begin your 5 minutes. Jury, the floor is yours.
Hello, thank you for the presentation. I was wondering, you are using QGIS to download the data from WAPR to calculate certain indicators? Yeah, what I was wondering, your target users are people that already understand a certain level, have a certain level of GIS. What does this app make for a difference to them? Because the WAPR data is intuitive, they can download it. So it's mostly the subsetting and the indicator calculation. But you still need a certain level of GIS. So how do you see this? What is the main benefit of this plugin?
Okay, so for your first question, the plugin is connected with the WAPR API, by a token. So the plugin is updating the data from WAPPR through the plugin and then to QGIS. So the thing is that you can use the plugin without internet connection. We actually need people, our target users, are people that have knowledge in QGIS. And the benefit of using the plugin is that you can have the WAPPR data without like internet connection, and you just have to select the WAPPR data that you need, and the plugin does everything for you. So it just if you just want a map from WAPPR, it just put the map from WAPPR in the QGIS canvas. Or if you want to calculate an indicator of water accounting and productivity indicator, the plugin is going to do that for the user.
Yeah, so it's mainly providing the API and providing a few indicators. Yeah.
Yes.
Thank you.
Hello, great presentation. I like the fact that you've done a lot of surveys to validate your assumptions. So this is great to know that you have done that. Now, one of the points that you have highlighted is that more than 50% are not willing to pay for this additional API to have on their system. Have you addressed why they're not willing to pay, and how would you diversify that? How would you be able to manage to get this API payable somehow, so that you can continue on updating it and providing the right information for your users?
I'll answer that one. So one thing, if we look at the platform where the plugin will be stored, QGIS in essence is open source. So no one goes to QGIS and no one plugs into QGIS with the expectation to pay. So that's an answer for that. And not just that, free, as you know, when something is free, it attracts a lot of users. So we use that as also an attraction method to bring in more users. So because it's also where we've got that target group of 20 countries, or that operational 20 governments, but we are targeting worldwide users. So we would like to use, and we would like to use the open source method to do that. And then for the second question, sorry, you said, could you just repeat it? The second part of the question.
It was, if you are not able to get people to pay for it, how would you how would you survive? How would you keep it? How would you keep it? Have you thought, for example, of selling the API to FAO, for example, or getting them to pay a recurring fee if the platform is their own, and so on? So how would you continue updating this API on the long run if you don't have sources of revenues?
Okay. So our sources, of course, we already outlined our other sources of revenue. So one, we would like to, we use the free, of course, we've got the free part, but we'll also enhance our app, our plugin for using tailor-made services for different partners and different clients that will request for this. So for example, if they would like to use their plugin for water and sanitation situations, we can, our team, our product development team can create tailor-made add-ons just for them, and we'll request for a service fee for that service. But also for the longevity of the product, we would like to use the community, and that's why we put our plugin on GitHub, the source code on GitHub. That way, a wider community will add into, will develop the code, and also apart from developing the code, they also check for bugs and things like that. So we'll want to use the community approach.
Great.
Great, thank you for your answers, and thank you, jury members, for your questions. The 5 minutes is up, so really nice session, and congratulations. Let's move on to our next team. We have Team 14. and their name is SIESP, or Showing Irrigation Efficiency Status by Phone. And they are working on the theme Big Data for Water Management. They have 6 people in their team, coming from Nigeria, India, Tunisia, Nigeria, again, Ethiopia, and Germany. So let's take a look at their video pitch.
For the past 2 weeks, Team 14 of the Water Productivity Hackathon have been working on how we can reach the last mile with remote sensing. And we have come up with a concept to show irrigation performance status via mobile phone. We realize this is a problem because over and under irrigation of farms is often due to insufficient knowledge on crop water requirements, which usually translates to overall reduction in water productivity for both upstream and downstream irrigators. This is because when farmers see their crops in poor health, their first approach is to add more water through irrigation, sometimes even more than needed. While other factors affect crop health, farmers usually do not know the right amount of water to apply to their farms. And this is where our concept of remote sensing data comes in. With remote sensing, we can evaluate the performance of a farm during the past growing season and use the knowledge to inform farmers on what they can do better. With our approach, we seek to leverage the cloud computing power of the Google Earth engine, pulling data from the WAPPLugin database to inform performance of irrigation. Required inputs will be GPS location of the farm and crop type submitted as USSD code for unskilled workers. Results on performance status are also delivered as an SMS in local language. First, the farmer needs to be on their farm and then enters a simple USSD code on their mobile phone. Then the farmer proceeds to select a language they are comfortable with. From this point, we require consent from the farmer to grant us access to their farm location. If the farmer selects no, the service terminates at this point. But if the farmer selects yes, they proceed to select the crop that was grown in the last irrigation season. The farmer will then proceed to select the performance indicator they wish to know for the previous season. And we additionally provide definition of the indicator to the farmer, who can proceed or go back to select another indicator. All these data, including location, farmer's language, crop type, desired indicator, are transferred to the Google Earth engine through an API gateway. In the Google Earth engine, we use a script to collect data from the WaPPLugin portal and calculate the desired indicator based on equations already developed by the WaterPIP project. The crop performance estimated as a simple number is compared to a performance benchmark using already established values from literature studies, from where we identify the performance status. This is translated into the farmer's language, which was selected in the previous step, and sent through an API to the farmers as a simple SMS. Most farmers do not know what the numbers mean, so we translate this benchmark into a statement which specifies the status as well as the existing gap. This way, we are meeting the farmers where they are with a simple statement rather than ambiguous numbers. The SMS service is free, but what do farmers do with this statement? How can they act upon the information we provide to improve their productivity? This is where we would be developing our business plan. We viewed this project knowing that major economic activities of world population is based on agriculture, specifically for less developed countries. Agriculture serves as a backbone to the economy, so our project is aimed at providing the crop performance easily through mobile phone. We are aimed at providing the irrigation performance indicators of crop through this mobile phone, and we are using free available data from the WaPPLugin portal, process it on the Google Earth engine, and deliver it through SMS to the farmers. In the short term, we aim at an initial development with level 1 data at 250 meter resolution, which is currently available on the Google Earth engine, with intention to move to level 2 and level 3 data based on viability and availability, thereby reaching more farmers. To provide information on crop performance, indicators for large irrigator schemes up to 250 millimeter resolution through mobile phone to help farmers improve their productivity, and we are harnessing already available mobile technology. We would later move to test and evaluate the viability of the app, cost revenue analysis with farmers, leaving the need we try to provide to estimate the value of the services we are trying to offer. And finally, we would modify the app in line with user feedback and target a specific market with outreach through universities, extension services, and international partners. The selling point of our app is the use of WaPPLugin data at initially 250-meter resolution for efficient irrigation water for regions with fiber data coverage. We realize that most mobile apps for smart irrigation are already in developed countries. They require internet connectivity, user account signing, and development of farm shapefile, as well as require smartphone and provide these figures as numbers. And we seek to leverage this by providing these indicators, these status, as simple SMS to farmers.
So thank you, Team 14. It's a really great video. And I like how you showcased all of your work. So with us in the room, we have Amali and Moti from Team 14. So if you could turn on your cameras and microphones, and I'll ask the same for the jury members. And then we can begin your 5-minute Q&A session.
Yeah, thank you for this really nice presentation. I have two questions maybe to the users and how they use the app. One question is, it's a great idea to really coming down from numbers and observations and science to information. How do you deal with that one? How do you translate from those numbers to the information delivered by SMS? And I mean, there's also I can imagine that it's work intensive, or are there any vocabularies already existing which you can use? That would be interesting.
Yes, thank you very much for the question. So to translate the numbers, we realized that using the WAPPLugin database, and we can have graphical visualization of what is currently existing. That is for advanced users. But we're targeting farmers with little or no knowledge of this available technology. And so what we intend to do with our app is that we arrive at a number, we compare it with a certain benchmark on performance indicators. So for example, we pick crop water productivity and we have benchmark for the particular crop. And so we compare this value with the benchmark, and we are able to say whether this is too much, too little, or just enough. And so we translate these numbers to statements and then relay them to the farmers as statements. So the simple question could be, the water consumption for your previous season was this particular amount, but you would have used less water and still achieve the same yield. Thank you.
But if in the last season, how do you know it was the same crop?
Well, we get information on the crop that was grown in the previous season, but depending on if the farmer wishes to proceed to grow the same crop on the farm or change to another crop, then we have this evaluation. But we can be certain for sure at the moment for perennial crops that are grown like for quite a long time. But for annual crop or seasonal crop that have tendency to be changed or to be modified, we cannot guarantee. But if the farmer decides to continue with this same crop, then we can evaluate for the previous season and also provide an indication for what to do for improvement in the next coming season.
Just a quick question. How do you get users to contribute to the, so yes, they may change their cropping patterns and you haven't anticipated this change. So what is the process where they just bring in new inputs in your system?
Well, maybe my colleague Moti would like to answer that.
Yeah, maybe. At this stage, we are on the first stage. Maybe our app always we open it for expertise, maybe for research or for any expert. We make it open and we take some feedback. So if we get such new input, maybe such new crop that's not in our system, we will include that one. For now, we are just on initial stage, so we are always update that one.
Thank you. It was a nice video. What I find difficult to understand is because farmers will only use it one time. I think it's not something you use on a regular basis. So it's a one-time solution. So is it, instead of the farmers, is it not more of interest for the basin authorities to use this app and to get an overall picture? So who is the actual user in your concept?
Well, in our concept, the actual user is the farmer at the last end of the production or the production value chain. At this point, we're targeting mainly the farmer. So yeah, we realize the tendency that the farmer can use this app only once or per cultivation season, but there's also the possibility, like we presented, to network with research organizations and institutions and universities also to see how they could collaborate in this app development using it for river basins also. But at the moment, we're targeting at how we could use this to help to inform farmers. And specifically what we intend to bring in is how do we provide this consulting service? So it's enough for the farmer to know what was the water consumption or what is the gap that exists, but how can that improve this particular gap? How can they bridge this particular gap? And this is where we develop our business plan to bring these consulting services in the different regions and also provide these advisory services to the farmers.
We have time for one more question. Does anyone from the jury have a short question?
Maybe just a question. And how do you, I mean, you indicated that it will be free SMS. How do you just maintain your system and get it financed?
Yes, so the SMS it's free at the moment, just utilizing just a simple GSM technology. But we plan also at a later stage to develop an advanced user platform. So using a mobile app hosted by the Google Play or also on the App Store for advanced users where they can enter location. But all these services we intend to provide it for free at this moment. After an initial stage of evaluation, testing the app in the market, then we can evaluate the value which our services are providing, and then we have an ability to monetize it depending on how much or what is the percentage increase or gain or reduction in terms of cost, almost also increase in terms of a revenue that the farmer has gained, and then we determine a monetary value for this. And this is usually based on the consulting services. So we hope that farmers are enticed enough to want to subscribe for the further consulting services, which we'll be providing them to help to improve or bridge this productivity gap.
Great, thank you everyone. Thank you Team 14 and thank you jury members. We had a nice Q&A session. And with this, I think we can move on to our fifth and final team of the day. We will share with you now Team 4. So Team 4, their team name is RIWEM, and they are working on the theme Remote Sensing for Environmental Issues. So they have 5 team members and they are all from Iran. So let's see what they have for us. Hans, can we play their video?
Hi everybody, we are here with WaPPLugin for Sustainable Ecosystem Management. The challenge ahead decision makers in basin management is how to share scarce water resources between its major stakeholders in a way none of them are damaged. Due to our desired outputs in this application, the most important one is the trade-off between agriculture revenue and environmental indicators. National and local decision makers in related sectors and also researchers could see what's happening in that region and determine optimal points and get a good understanding of their current position. The other point worth mentioning is that by knowing unit water value output, we can guide water allocation management toward path in which we have crops with more unit water value, and then more water is saved for environment. In this application and in agriculture data, we use 3 different vapor layers such as ET, precipitation, productivity. Effective precipitation is calculated using FAO lookup table. In the next step, it should be specified whether we have crop map in this area. Otherwise, calculation should be done by different crops area percentage in the region. And at the end, calculation for deriving agriculture revenue is mentioned. Crop price could be used from both of FAO and World Bank. Environmental data like water level could be accessed through both national and global accessible database. That here we used HydroWeb radio altimetry. For retrieving accessible datasets, we have 2 ways. First, vapor data can be directly fetched from the server on client. That client could be web browser or application, and calculations are done on the client machine. It has two disadvantages. The first is the time of processing, and the second is that the data request to the WaPPR server largely increases. So we use a server that our client requests for datasets and cache them if they are not already available in its storage. Also, calculations could be stored. Fortunately, WaPPR gives us an access to API. For websites that access us to API, we use that, and for others, we could request for an API or we can use a crawler. Here you could see a prototype. In time menu, you could select a single date or date range. Now we select year 2009 to 2018. In location menu, we can select location by country or crop map. Due to lack of crop map in continental level, we can upload our desired crop map. Note that your crop map should be in a specific structure so that it can be processed by server. When we select date range, we should upload a separate crop map for each year. Also, we can filter crops that we want to calculate agricultural revenue with them. Since the website is linked with HydroShare database, after selecting crop map, it could distinguish that which environmental data is available in crop map geographical position. There are several choices to be selected among environmental data to be compared with agricultural revenue. In output menu, data with different formats have been put so we could download the preferred. This is agricultural revenue that we calculated with WaPPR data for 2008 to 2018. And here is the trade-off diagram. For future steps, we should standardize our mathematical methods and document it. We should design a library that could conduct methods. The library could be designed by a developer and we can upload it on GitHub. We can also use this library to design RESTful API. We would like to cooperate with a developing team in the future so that they would be responsible for updates and maintenance.
Great video, Team 4, and thank you for sharing your idea with us. And now it's time for your Q&A session with the jury. So in the room, we have Amin and Sumayya with us. So I'll ask you to turn on your cameras and microphones, same with the jury. And now we can start our 5-minute Q&A session.
So a quick question, who is your target group for this application? And how do you, I mean, just a follow-up question, and how do you just, you focus on the value of water, but how do you just give a value to environmental, for example, nature uses?
Yes. Actually, we have different stakeholder and users from our app. At the national level, environmental agencies, NGOs, and researchers can use our application. And at international level, environmental organizations like, for example, Ramsar Convention on Wetlands or UNDP can take advantage of our apps. And the idea here, as you saw, is to link somehow the environmental changes to some agroeconomic values, agroeconomic variables, to see how they interact with each other. So we want to show that sometimes we have to sacrifice some part of our agricultural revenue for the sake of environment. Our application provide a tool to make this trade-off more clear and inform people from different groups to see how this trade-off may change during a time. I don't know if I could answer.
Yes.
Yeah, related to that question, thank you for your presentation. I like this original idea of putting things together. But related to the question before, how do you plan to finance this? What's the business model behind it?
To be honest, right now, we just validated the product with some of our national organizations, for example, Iran Environmental Organization, and they are willing to help us to develop the app. But we don't have any signed contract on the table or something like that.
But will it then be an open access app, or will it be owned by this national organization?
Definitely open source app at the first stage of development, and then maybe further when we try to add value to the application by extending our data sources, we can think of getting financial support to further develop it, or even provide special services for private sectors.
Could you say, I like the video, also the music, by the way, but is it an operational app? Because I understood also you have the lake levels included. Is it lake level included in such a way that it relates directly to the availability of water? So I mean, the crop decision is also based on the lake level, for example. So it's really a basin thinking how you deal with the whole app, is it? I mean, they're the main stakeholder, in fact, the main user. Is that correct?
Yes, you're right. You know what? The trade-off is always usually hard to cope with and make it clear for everyone. We try to use global open source satellite data portals like RIWEM, which uses radar altimetry data to show the water level fluctuation of the main lakes throughout the world, and link this freely available data to some agroeconomic variables that we can calculate from using from vapor data. Except these free open source data sources for water level of the lakes, we can use also our national data, because, for example, at national scale, we have water level data for a bunch of lakes, and also even for rivers, environmental flows. We have hydrometric data at national scale, and we can feed them in the future state to the system and see how the water allocation for the river is affected by the expansion of agricultural development and crop choices or yield or productivity, how these different kind of choices interact with each other and affect the sustainability of the land and our water resources.
Great, thank you for your responses, and thank you, jury members, for your questions. We have reached our 5 minutes, so now we have seen all 5 teams and all 5 pitches, and I want to say congratulations to everyone. I'm very impressed with all the work that went into it and all your explanations and the creativity. of your apps. So now the jury members have a difficult choice ahead of them. Out of all of these great teams, who's going to be the winner? We'll give the jury about 20 or 25 minutes to decide, but for everyone else, let's take a short break. We'll have the jury members go to their jury room so that they can have a discussion, and we'll take a 5-minute break so people can get up and stretch and get a glass of water or something to eat, and then we'll be back with our guest speaker. But don't forget, during the break, we'll put up a link on the screen so you can vote for your favorite pitch, and when we return, we'll let you know who the fan favorite was. Okay, so I think we've had a few minutes break. Apologize if it was a little bit longer, but I think it's always good to have a few minutes to stretch and get something to drink. So before we have our guest speaker, I would actually like to share the results with you of the fan favorite. So thank you all for voting. Let me just share this. Finals. Okay, so we had 34 people vote, so thank you for your votes. And it looks like we have a clear winner with Team 17, with the WAPPlugin development team. So congratulations. I think all the video pitches were good, but it seems like this is the one that won the hearts of our viewers. So congratulations to Team 17. And now I would like to introduce our guest speaker for today. His name is Kees Oude Lenferink, and I would like to welcome him to the live session. And he'll be talking about satellites and geodata for agriculture and water. So Kees works at the Netherlands Space Office, NSO, the space agency of the Dutch government, and an advisor on satellite applications. In this role, he advises users on how they can benefit from space technology, such as Earth observations, navigation, and satellite communication. Furthermore, he is an advisor in the team carrying out the Geodata for Agriculture and Water, G4AW program, commissioned by DGIS, revolving around the application of satellite and geodata-based services benefiting food producers in various countries in Africa and Asia. And in a previous position at the water team of the Netherlands Ministry of Foreign Affairs, he played a supporting role in setting up the WAPPlugin program. So he's very familiar with the theme of our hackathon. A quick note for our audience, if you have any questions for Kees, please put them in the chat box in YouTube and we will take note of them and ask them at the end of his presentation. So Kees, we're very happy to have you with us today.
Excellent. Thank you, Lauren. It's a pleasure to speak today. And before I start my story, like Lauren just said, I have assisted Job Klein in a previous position in the Ministry of Foreign Affairs, where WAPPer was designed. And I just have to say, wow. I mean, if you now look at how far we've come and the quality of the proposals this hackathon has resulted in, I have to say I'm just very impressed. So whatever the verdict of the jury is going to be that we're going to see in a bit time, I just would like to congratulate all the participants for making it this far and coming up with such good proposals, especially considering the fact that you've been working across countries, across continents and across time zones, which makes cooperation sometimes even more tricky. So in that sense, I have to say I'm just very impressed, and yeah, you should all be proud of yourself in that respect already. Now I'm happy to introduce the Netherlands Space Office in a bit more detail to you. So I'll just activate my slides right here. The Netherlands Space Office is indeed the space agency of the Netherlands government. It was established in 2009, and what we effectively do is that we an interest in space generally. Okay, I hope everything went well. Okay.
Yes, you can continue, Kees. Thank you.
Excellent. Thank you very much. So we work for various ministries, including the Economic Affairs Ministry, who also works a lot on innovation policy, but also for the Ministry of Infrastructure and Water Management, Ministry for Education, Culture and Science, and particularly for the G4AW program, we also report to the Ministry of Foreign Affairs. Furthermore, we also work much together with the Netherlands Organization for Scientific Research. Why do we work for this? Well, I mean, one thing is to develop the space program, but we're also very much looking in how we can actually use all the investments that we made in space to benefit as many users on the ground again. So we don't only look at the front part where, for instance, you work with the rockets and the satellite development, but we also focus very strongly on how all that investment can be translated into useful outcomes for users in the Netherlands and beyond. So how does this work? Well, there's a strong emphasis on international cooperation. So most of the Netherlands space activities we actually do together with various other European countries, and predominantly we do that through the European Space Agency, ESA. Netherlands has been a founding member and is contributing at this moment approximately 85 million euros on average. Also, Netherlands is host to the ESA ESTEC complex in Noordwijk, where a lot of space-related research is carried out. So we work in the ESA, we work together with various European countries. Some of them are EU members, but we also work together in ESA with certain non-EU members, for instance, Switzerland, Norway, and the United Kingdom at this point. And that's, for instance, the level through which we also participate in various international cooperations, including the International Space Stations, where humans are in space, and several other programs of ESA. Also, we've seen that recently the European Union itself has become more active in space, for instance, by taking the initiative to set up Galileo, which is the European version of satellite navigation, such as GPS, and also the Copernicus program, which is focusing on the various satellite and observations that are being made on the Earth. Actually, in that field, you do see there's a strong interaction between the EU on one side and ESA on the other side. So essentially, you could say that through both ESA and EU, Netherlands is active in space. Furthermore, we also look for opportunities to cooperate with members beyond the EU and ESA. So we also have some interactions with organizations such as NASA from the United States, ISRO from India, or the Ukrainian Space Agency. Of course, we don't do this alone. We are a government agency that controls and in a way is a broker between several space activities in the Netherlands. A lot of the space activities in the Netherlands are carried out by the sector. We are active on a wide range of activities going from the development of parts for rockets and satellites all the way to services where satellite data are being translated into useful information for end users. So in that sense, a lot of the activities that the Netherlands carries out is actually being carried out by the various universities, knowledge institutes, and private sector parties that we have in the Netherlands. Also, we're keen to stimulate new enterprises and innovations. For instance, through the support through the Space Business Innovation Center in Noordwijk, and also through several programs of ESA, including the ESA Incubed program, where we stimulate new innovations, both from existing companies, but also from new startups. Like I said, we focus a lot in NSO in stimulating uptake. There are several programs that provide space services for observation and navigation. And what we often do as the Netherlands Space Office is that we actually challenge the sector, the private sector and the knowledge institutes in the Netherlands to translate all of that information and all these services that exist and come from space into useful information products for several parties. So recently we've been supporting several organizations in the Netherlands, including the Ministry of Defense or the Dutch water boards, who have been able to work more effectively and more intelligently using satellite data services that are being developed by the private sector. There's a few current major trends that we actually see in the space landscape and that also will be relevant in the time to come. The most important one is that we see an increasing resolution and sharpness of satellite sensors, which enables you to see more information, more detailed on the Earth's surface, which then also makes the information products, such as WaPPLugin, more sharp over time. Also, we see a development towards so-called higher spectral density, so where you can see, in more detail what type of colors there are, and you can recognize the spectral fingerprints of certain objects more clearly. And we just see a big increase in data availability. So there's easier and faster access to enormous data volumes, for example, from the Sentinel program or the Landsat satellites. And also WaPPLugin is an example of that. We actually see that compared to 10 years ago, for users and entrepreneurs and researchers, it's been so much easier to access really big amounts of data and to work forward on that for their research or for their services. Also, the longer these satellites are active, we actually see that the time series of those satellites, of course, become longer. And that, of course, enables users to detect more long-term trends in the data. So that also benefits and supports use over there. Secondly, we also see an increasing computational power of computers. As you might have realized, the computers we use today nowadays are a lot stronger than we had 10 years ago. And that also definitely benefits the Earth observation community, because more complex analysis can be carried out and also just become more affordable to carry out. Also, there are new forms of data analysis coming up, most importantly, machine learning and deep learning, which play an important role, for instance, in object recognition. So you see now that certain algorithms are being developed, for instance, to detect changes around roads and waterworks. And we have seen some really promising results. Also, we see the development of relatively smaller satellites, for instance, CubeSats, which are roughly the size of 2 milk cartons. And that just makes the idea of creating a satellite for your own purpose and bringing it to space a lot more achievable for particular sort of users. So it's bringing down the cost in a way of access to space in the first place. Specifically, I would like to point out the G4AW program, which is carried out by NSO. In a way, you could say this is a cousin to WAPR, because it's also supported by the Ministry of Foreign Affairs, and it's also strongly based on satellite data. Our main focus is to improve food security in developing countries by using this sort of data. And we do that through setting up particular projects in which consortia of data providers, technical operators, and agricultural specialists work together to come up with information products that help farmers. And the objective in there is to come up with a sustainable business case after several years. So far, since 2014, we've launched 25 projects across 15 countries in Southeastern Asia and Africa so far. So we're making good advances there. The concept is that we combine several expertises, for instance, from both Dutch parties, but also parties in particular countries. We combine parties with both commercial roles, knowledge roles, and, for instance, an NGO role. And we have consortia with parties with varying expertises, for instance, geodata specialized or agri-specialized. So we're bringing together all of these expertises in developing certain information services in which satellite and geodata play a very important role. This can result in a variety of different services. It can be advisory apps that directly advise the farmer. It can be financial services. For instance, it make it easier for farmers to get crop insurance. We also sometimes don't target the farmer directly, but we actually target the advisors to the farmers, who then go and talk to the farmers and discuss with them how they can improve their operations and have higher yields, use less water, or use less pesticides, for instance. Another form how we use food producers is by giving them advice by phone or through SMS services. In the end, those services will reach the food producers, and we hope that will help them to operate better, increase their yields and incomes, and to work in a more sustainable manner. We've been doing this for several years, and we have some key insights in here. One of the insights is that there is a strong role for so-called integrators and agro-business intermediaries, the people who sit between the food producers at one side and the trade on the other side. Usually they have the punch and also the financial means to make sure that such a service can keep existing also after the project phase, and also make sure so the developed project and service is sustainable. We also have seen that attaining a sustainable business case just requires time and commitment. So sometimes it can really take several years before you really have the wheel and have enough momentum to keep the service running. And that we've also seen that for a good service, you should not just look at satellite data alone, but you definitely have to see how you can combine that satellite data with other forms of data that can, for instance, be weather data or hydrological data, but also this can relate to data and information about the farmers themselves. Which leads me to the second slide, where I'd like to point out the importance of so-called business intelligence. In order to provide a service as optimal as possible, we do see that you want to go to informed decision-making. So collecting information also about the food producers and their context and their struggles is very important to understand what your farmer really needs. And the better you can translate those needs into your service and you keep a cyclical process going on, the more successful your app can be, and the bigger the chance is that also after the project ends, you have a sustainable service, a sustainable business case that will also last post-project phase. So in a nutshell, that is what I would like to share about the G4AW program, where we've been standing. Also, particularly, I would like to point out to the groups that have presented today that are several ways where the Dutch government also likes to stimulate innovation and entrepreneurship also beyond the Netherlands. I'd like to suggest that you check out Orange Corners, which you can find at orangecorners.com, where the Dutch government tries to boost innovation and entrepreneurship in countries abroad. And furthermore, I would like to point out that there is this program called Water and Energy for Food, we4f.org, where also the Dutch, together with several other donors, are looking for innovations in the field of water, energy, and food in particular countries, for instance, in the MENA region. So that might also be an interesting angle to look at. Well, thank you for your time, and if you have any questions, I'll be happy to answer them. Thank you.
Thank you, Kees. A really nice presentation. I know I learned a lot, and I appreciate how there's a lot more than just data. There's bringing in different people in the supply chain. There's also ensuring that business knowledge gets incorporated along with just the remote sensing data. So it's a really nice approach to see that's pretty comprehensive.
Thank you.
So, but I do have a question. You see in, let's say, movies, or we have these military satellites that have this incredible resolution for satellites, information from satellites, and yet we're still in the agricultural sector. Sometimes we struggle with the resolution of the data available. As we work forward in the future with new satellites and new technology, even things like AI or other, let's say, computer-based methods, do you think, or how do you see the future of remote sensing for agriculture, and what kind of resolution do you think we'll get to?
Oh, that's a very good question, and there's always a trade-off of what you want. We know, of course, there are military satellites active that operate at very high resolutions, but that's usually the type of satellites which information we cannot use for this kind of agricultural service. The most important source for a lot of the services we see are the satellites from the Copernicus and Landsat programs of the European Union and the United States. And we do see that there are commercial providers who come up with even sharper satellite data. They go below a meter, so you can start to identify particular objects even at street level. My expectation is that as technology increases and more of these initiatives come up, and as I pointed out, access to space is becoming more and more affordable very quickly at this point in time. I do expect that we're going to see examples of more and detailed footage coming up. Maybe not so much directly in the short term, but definitely on the medium term. I think that also will have an impact on the big programs that share data for free, for instance, Copernicus and Landsat. Whereas, because that sharp data from that satellite cannot be used straight away in the WaPPLugin portal. I mean, there is an integration process going on there. The companies specialized in carrying that out. And I think that they will also benefit from the increases in computational speed that we've seen so far. So all in all, I think it's a pretty positive future that we're heading to. Certainly in a few years' time from now.
Yeah, I like your positive attitude. So I think it also motivates us to stay in the sector and keep innovating. And with our creative ideas, pretty soon the technology will be able to meet our ideas. I think we have time for maybe one or two more questions. So something that I was curious about is you talk about data and how it integrates into the decision-making process. Do you have any tips maybe for our team members? There are many videos that said, okay, we'll take this data and take it to community and we'll use it for decision-making. So, based on your experience with the projects that you've run, what are ways that can help the decision-making process run more smoothly, especially around remote sensing data and maybe the trust of remote sensing data for some of these community groups?
That's an excellent question. And that's also something we've seen in the various 25 projects that we've seen in the G4AW program. I think when it comes to trust, I think it's important that you can translate the insights you can see from the satellites with what you see happening on the Earth. I mean, if your satellite algorithm would tell you the land and the cropland would be very wet, but the farmer just sees a very dry land, then of course that would not build trust. So I think local presence, after all, does matter in making sure that you can really make that next leap from the satellite information to a service that really benefits farmers. And it's a very good way, in a way, to prove that your service is relevant for them, and they can use your service to do their agricultural planning and base that on. And also generally, that local interaction also just helps you in understanding what the farmer really needs, and it will also assist you in really optimizing the sort of information that you will provide to the food producer.
All right, thanks. Nice advice. And I think we have one question from the YouTube chat, and it's about using remote sensing for groundwater monitoring. So many countries in water-stressed areas, like the MENA region, for example, they irrigate from groundwater. So is there any advances coming for using remote sensing for understanding groundwater changes or availability? I know it's a tough topic, but I think people are very interested to see if there's new innovations on the horizon.
Well, this is a very good point, because usually, well, satellites take pictures of the Earth, and if you take a picture, you might see clouds. Well, hope there's no clouds. You might see the land. So we can tell a lot about the land and the surface. What's happening below that is a bit more difficult because we can't always see that. We have seen recent big advances when it comes to soil moisture, but that's of course only the top layer. But if you really want to go to aquifer level, it becomes a bit more difficult. However, it's not completely impossible. For instance, there are missions where instead of sensing and seeing what's happening on the land surface, we actually sense what's happening in the Earth gravitational balance. You can imagine if there's a lot of water mass sitting deep in the Earth, then also the gravity profile of that place in the Earth will be slightly different. And there are very sensitive missions where experiments are being carried out, whether that can tell us something also about groundwater, as well as land ice, for instance. And that could give you some information there. A second option is, for instance, to combine remote sensing with hydrological tools and see if you can detect, for instance, lakes or streams that are drying up, and see if you can combine that as input into a hydrological tool and see if that gives you a particular insight through modeling about the conditions of groundwater in your system. So there's various approaches. It's not by definition impossible, and that's good. Yeah.
Great. We love to know that nothing is impossible. Well, I would like to thank you, Kees. I think a really great presentation, a nice Q&A session. I know we're all very excited to know more about the work that you're doing. For the viewers, I did put those two links that Kees mentioned in the chat box, so please take a look at those. I think particularly for our teams here that have their concepts pretty developed and are working towards a prototype, there could be some interesting opportunities available for them for some collaboration with the Dutch government.
Excellent. Thank you.
And so I think we will have a few moments. We're going to invite our jury members back into the room, but I think they're doing some final deliberations. So what I would like to say is, while we have a few minutes, this hackathon has been a really great experience for us and our team. So I'd like to thank all the people that make it a reality. So first, the WaterPIP project partners for supporting this event. So that includes IHE Delft, Institute for Water Education, Meta Research, Wageningen University and Research, and then our supporting partners who we work very closely with, FAO and ELEAF. And of course, an event like this doesn't happen without financial support. So a big thank you to the Dutch Ministry of Foreign Affairs and the IHE Delft Partnership Program for Water and Development. I also want to thank my fellow hack team organizers as well. I know a lot of work has been put into this, and late nights and weekends. We learned a lot, and we were all very happy to be working with you all, the participants and the coaches, the guest speakers and the jury members. I know some people did not participate, but were very curious to know what was happening in the hackathon. So you've watched the YouTube videos and you've attended the live sessions. So we also want to thank you. Your interest and support is also very important, and we would like to keep engaging with everyone. You, the participants, the jury members, everyone. So if you would like to stay in touch with what's happening on the WaterPIP project, you can always go to our website, which is waterpip.un-ihe.org. I can put that in the YouTube chat. And we also have a Twitter and a YouTube page, which I think you're on at the moment, where you can keep in touch. So follow us on YouTube and subscribe to our channel on YouTube, and follow us on Twitter, and then you can be up to speed on what's happening with the WaterPIP project. So we have a lot more events coming up in the upcoming years, all around WAPWAR and water productivity. So I think it would be great to stay in touch, and there'll be, more events, more webinars, things like this. So be really happy to keep engaging with you guys over the upcoming years. Okay, so now it looks like our jury members are back and they are ready to share their results. So I want to thank all of you jury members for taking the time and thinking very hard about who the winner should be. So now I'm going to hand this over to Simon, who is working with our jury members, and he will moderate the final results.
Hello, good morning, everybody. Sorry for the delay. Again, it's really great to have all the presentations. I will not do a lot of talking. The order will be that we will first have the jury reflect on every team. So every jury member will have a short reflection on one specific team. And then after that, we will do the announcement of the winners. So I'd like to go from, because the presentations were from 36 to 4. So Job, can we go maybe from 4 back up? Job, if you would like to comment on team 4 and their presentation on the RIWEM case. Yeah.
Yes, thank you. Let me just take some water. Well, 4 is the one on the lake and the environment. Yeah, I know what, because I mean, you're still not going to announce the winners. So I mean, we just give a general perspective. It's environmental. The link between our environmental and the water is an important aspect of this one. It's not only the music on the video, that was also nice, but it's really in fact the link between the environment and the policy. In fact, so it really gathers up from top down and bottom up. So it's really the policymakers that are involved now in the water productivity. So it's functional, it's usable, and I leave it with this.
Yeah. Okay. Great. Thanks. We'll go over to team 14, which was the team on showing irrigation efficiency performance stats by phone. Annemarie, you were going to say something to team 14.
Yes, thank you, team 14. I think it was a very nice idea, and it's very much in line with what WAPPWAR is, the objective of WAPPWAR, so what we are looking for to improve water management using big data. However, what we also notice is that you're very much aiming at farmers currently, and I think that with the, if you're using level 1 data, it would be much better to focus on water authorities and look at a bit of a higher level. So it probably would need a bit more work on that. Who is your exact user and how are you going to implement it? But the overall, the starting point is very nice. Thank you for that.
Great, thanks for those words, Annemarie. We'll go over to team 17. Stefan, over to you. Team 17 was about the WaPPlugin development team.
Yes, thank you also from my side for this nice presentation and the impact of a plugin for QGIS. We discussed a little bit about developing plugins and if it's needed necessary to do a hackathon to do that. On the other side, it's the aim is to have a user-friendly WaPPlugin to solve issues and could be addressed by other or by the end users. And in particular, we also think that this plugin could have potential and direct influence of supporting and enhancing the WaPPR platform by using open source platforms like QGIS. Thank you.
Yeah, thank you, Stefan, for those words. We are climbing up and we're going to team 30. Team 30 was the Gaming for Crops team. Domitil, over to you to share some feedback, a feed forward for the team 30.
Yes, so thank you very much, Team 30. It's, I think the idea is excellent. It's really, needed to just understand and try to guide on better cropping patterns and just getting farmers and managers element of decisions. And I think there is a very good basis to do that. But as you indicated, maybe you took a case a bit complex because a country with limited data and so there is probably more work needed to just really demonstrate the feasibility of the idea. But I will recommend that you go forward because it would be a very innovative and useful work.
Thank you for that, Domitil. Last but certainly not least is team 36. We started with them all the way at the beginning of the morning. It's the Grazing guide. Rami, yeah, over to you.
Perfect. Okay, great. Team 36, your idea was very interesting. I'm always a fan of seeing how smallholder farmers and herders can benefit from technology. And I think you have a very interesting platform to look at. My question would be to you to really go and validate how the technology would be accepted by the smallholder herders, how those communities interact with technology, how would the data be translated into their practices, and how things happen on the ground. So maybe connecting with people on the ground, trying to test, storyboards or anything that could get them to really think it through and get back feedback. I think this is a case that is growing in the region. People are fighting over land and water and grazing facilities. If you can make peace with that, that would be great. Good luck.
Right, thank you. Thank you for that. Lauren, maybe you can join. I'm presuming we now really want to get to know who the winners are. Before that, I would really like to thank the jury. Rami, Domitil, Annemarie, Stefan, Job, Gregory, who may be watching online. Big thanks for you, for your efforts, for joining. Really appreciate it. Hope you've also enjoyed. The moment of truth. I would like a jury member, but we hadn't discussed actually who. But maybe one of the jury members can raise their hands to wants to announce the winners. Is Job maybe willing to announce the winners? You're still aware there, Job, of who the winners are? Oh yeah, you just have to unmute, Job. So yeah, no, I would like to. Oh yeah, you just have to unmute. Yeah, no worries. Yeah, oh, you still have to unmute. Yeah.
Okay.
That's it.
Yeah, no, after our discussions, for me to have the honor to announce a winner is too much. So I will just mention one. Then we just have all five, then we have all five, you have something. No.
Well,
yeah, say something. Yeah.
Well, then maybe before, if you're going to mention one, then I think Job has revealed the secret that our jury was at the end unanimous, that the first prize could not go to one team, but we had to say a split between two teams. So then what I'll do is I'll invite Job to announce the first winner, and Rami maybe the second winner. Yeah, over to you, Job, to announce the first winner, and then we'll have Rami immediately to follow up with the second and equal winner of this hackathon.
Number 4.
Number 4.
And it's number, sorry, I have to look at my sheet. I know it is the API. I think it's 17, isn't it?
It's team number 17, indeed.
It's
yes.
the API. It's the API app.
Okay.
Yeah, so that's the result of the jury. Team 4 and 17, congratulations. But all the teams, a lot of, big thumbs up from the jury. And I'll hand you now over to Lauren to wrap it up.
Yeah, so the jury is always full of surprises. Last week, instead of 4 finalists, we have 5, and now instead of 1 winner, we have 2. I think it's great. I think has been said, all of the participants and all of the teams have done a great job. And you guys made it really difficult to choose just one. So, we're happy to support 2 teams, and I know our partners are too. So again, congratulations. So what I think we had wanted some of the people from the winning teams to come in, but we're running a little short on time. So I think we'll just say congratulations from all of us, and the WaterPIP, the hack team, will be in touch with all the teams, so the 2 winning teams and the other finalist teams, probably today or tomorrow. So keep an eye out for your messages, for a message from us. And with that, we now have arrived at the end of our WAPPLugin hackathon. So it's been a great 3 weeks, and we couldn't be happier with the outcomes. We are especially thrilled to have people from so many countries. I think a few people have commented on this, but it really was a global hackathon approaching global challenges. So thank you all to the participants for your great work and your dedication. I know we also asked a lot of you over the last 3 weeks, so thank you for taking time away from your jobs and your families to do this event with us. You showed us all new and creative ways of using WaPPLugin, and we hope that you also enjoyed the challenge. And again, a big thank you to everyone who made this event a success. So our jury members, our experts, our coaches, and our guest speakers, as well as the hack organizing team, the hack team. So with that, I would just like to say thank you all, and let's keep in touch. So for the WaterPIP project, you can follow us on our Twitter page and our YouTube. So if you subscribe to this YouTube channel, you'll stay in touch with our latest videos. And you can also take a look at our website, which I'll put in the YouTube chat. So from all of us, thank you, and we'll see you again soon.
Thank you, Lauren, and thank you, Hans.
Okay, thank you.